Okay, so I'm at the ocean, right? Wait, I was gonna do a little of this, a little swimming action. What happened? I'm too late? Well, by how much? Oh, that's a long time. Well, maybe I'll go rock climbing instead. Welcome to Field Notes, California. I'm Brendan, and we're in one of my favorite places in the world. We're in Joshua Tree National Park. And today, we're gonna scramble up this peak here, and we're going to look at the biggest of big pictures, the planet, and how it changes as a whole over time. And then we're gonna zoom in closer and closer and closer to see how individual landforms change, and then how rocks change over time. The first thing that we need to think about is, I've got my Field Notes notebook here. That's so cool. Anyway, plate tectonics. Come on down and let's draw it out. The impact of plate tectonics on what the landscape looks like is big, like planetary big. If you were to cut a slice out of the Earth, you would see that it has three main parts: the outer crust, the mantle, and the core. The mantle is mostly solid, but not all of it is. The rock in the upper mantle flows and churns because of intense pressure and heat, especially near the tectonic plate boundaries. Our planet's outermost crust is made up of a dozen major plates and several smaller ones. These tectonic plates are constantly in motion because of the currents of the mantle, which drags the plates across the Earth's surface before pulling the plates back down into the mantle to be melted and pushed up in a different location, kind of like a conveyor belt. Plates interact with each other along boundaries. There are four main types of boundaries. Convergent boundaries, where crust is destroyed as one plate dives under another. Divergent boundaries, where new crust is generated as the plates pull away from each other. Transform boundaries, where the crust is neither produced nor destroyed as the plates slide horizontally past each other. And plate boundary zones. These are broad belts which boundaries are not well defined, and the effects of plate interaction are unclear. These boundaries cause both rapid and slow landform change. For example, when two plates converge, the heavier, denser plate is subducted or driven beneath the lighter plate. This subduction can slowly form volcanoes and mountains. Subduction can also cause rapid landform change, such as earthquakes and volcanic eruptions. If two convergent plates are of similar weight and density, the crust near the boundary buckles and wrinkles, which slowly forms new mountains and plateaus and can cause earthquakes. Divergent boundaries. So divergent boundaries are found in places on the Earth where new crust is being created by magma that is getting pushed out of the mantle. Because of this, volcanoes form near divergent boundaries. The grinding plates along a transform boundary churns the crust, creating mountains, such as the transverse ranges near Los Angeles. But what these boundaries are famous for is earthquakes. For example, the San Andreas Fault is responsible for the earthquakes we regularly experience here in California. Now that we know how plate tectonics work and how they shape the landscape, let's climb up a little ways further, and we'll talk about some other slower processes that shapes the Earth once things have been formed. So let's go. So we're pretty close to the top here, and this is a great place to talk about weathering, erosion, and deposition. And these are slow processes that tear down mountains and big landforms that are high above the ground. So if you look down in the valley below, you can see all of these boulders. It's strewn with boulders down here. And these boulders came off of this rock all around us. And it came off because of weathering. Water will cause chemical weathering. Every time it rains, every time it pools a little bit, it dissolves the rock just a little bit. And then after it dries out, anything that gets dissolved out of there can get blown away in the wind. There can be physical weathering, and a good example of this is ice. So if water gets into a crack while it's freezing at nighttime, it'll freeze and then it'll expand in the night. And each time it does that, it wedges the crack apart a little bit. Lastly, there's biological weathering. Biological weathering does a little bit of both. It can be lichen, and so that's a chemical kind of weathering. The lichen actually eats the rock. Or it could be plants, and plants will get their roots into the rock and slowly break it apart. So as the rock gets weathered, gravity will eventually pull it off, and then it erodes, it gets swept away by the wind and the rain in particular. Here in Joshua Tree, believe it or not, there's flooding in the fall, and that flooding will wash away a lot of rock and debris, and that'll get deposited downstream and potentially even down in the ocean. This is where we start seeing sand and broken apart little pieces of rock getting sandwiched on top of each other. And then over the course of millions and billions of years, they get pushed together and cemented, and they'll actually form a new rock. And that gets into what we're going to talk about in our next video, which will be all about the rock cycle. So thanks for watching. I hope you enjoyed this. I had a blast, and you take care. I'm Brendan. Thanks for watching Field Notes California.